We are in Pre-Calculus Tech Math 3, and we're in section 15-2, which is the multiplication of matrices. Okay, so we'll go and we have two matrices, A11, A12, A21, A22. So that's A11 is the element, first row, first column. A12, first row, second column. We're going to multiply that times B11, B12, C21, C22. And we see that this is 2 by 2, and we're multiplying that by a guy that's 2 by 2. We can only do that multiplication if the number of columns in this guy is the same as the number of rows in that guy. It is, so we can do the multiplication. And when we get done, our answer is going to be 2 by 2. So our answer is going to be 2 by 2 when we get done. All right, so what we're going to do is we're going to take the first row and multiply it by the first column of the second guy and say that that's A11, B11 plus A12, C21. A11, B11, A12, C21. That's one element. That's all it is. Then we're going to take the first row, different color, first row, multiply it by the second column. How come I'm not on the first row? I'll try it again. We're going to take the first row and multiply it by the second column. I'm going to get A11, B12 plus A A11, B12 plus A12, C. Why did I put C's down there for?
I have no idea.
Oh, gee. So anyway, that's just another element. Well, I did, so that's what it's going to be. Okay, then we're going to take the second row times the first column. A21, B11 plus A22, C21. And then we're going to take the second row times the second column. A21, B12 plus A22, C22. And that's going to be our answer. Now, with a little bit of luck, those are all going to be numbers. We're going to be able to put them in our head, and they're going to end up in the spot. But that's one element. That's one element of the, and this is one separate element there. That's one separate element over there. Okay, good enough? Okay, so if we do it another 30 times, it ought to be okay. Now, your calculators will do this for you, so that's the good news. Okay, so I'm looking at problem number 2. Problem number 2 says minus 142 times 0 to 5. Okay, so the first thing I do is look at the order. This guy's 1 by 3. This guy's 3 by 1. I see that my number of columns here equal my number of rows there, so I'm okay. My answer is going to be a 1 by 1 matrix. How big is a 1 by 1 matrix?
I think it's like 1.
Yeah, it's like one number, right? That's all there is. All right, so I take my first row by the first column. 1 times 0 is 0. 2 times 4 is 8. 8 plus 10 is 18. The answer is 18. That's all there is. There ain't no more. Minus 1 times 0 plus 4 times 2 plus 2 times 5 equals 0 plus 8 plus 10, 18. Now, I could have taken my calculator, and assuming I had power, I could have gone to Matrix, and I could have gone to Edit, and I could have edited the first guy, 1 row, 3 columns, and I could have entered a minus 1, 4, 2. And then I could have gone to edit the second matrix B and called it a 3 by 1 and put in a 0, a 2, and a 5. And then I could have gone to math. No, I don't want math. I could have gone and I could say matrix A times matrix B equals 18. And my calculator would have told me 18, and I would have been so happy. Okay, so the calculator will do it for you. When they're that easy, I wouldn't do that.
That way you can almost do better when you're noggin.
Yeah, exactly. You can do it in your head. Number 4. 1 minus 3, 1, 6, minus 2, 3. Okay, this is 1 by 2. This is 2 by 2. These two numbers are the same. I can do the multiplication. When I get done, I've got a 1 by 2 guy. First row, first column. 1 minus 18 for a minus 17. Minus 2, minus 9 more, minus 11. That's all there is. There ain't no more. Okay, first row times the first column, first number. First row times the second column, second number. That doesn't look like a 1 by 2 to me. Does it look like a 1 by 2 to you? Oh, what is my big eraser? That's better. First row, first column, minus 17. First row, second column, minus 11. There, that's better. Misspelled it. Okay, we're going to look at number 6. One minus 1, minus 3, 6. 2, 0, minus 1, 3. This is a 2 by 2 multiplied by a 2 by 2. We can do the multiplication because those columns are the same as those rows. When we get done, we're going to have a 2 by 2 matrix. All right, first row, first column, 2. First row, second column, minus 10. Second row, first column, minus 2. First row, second row, second column, 19. And I can do that quicker than I can put it in my calculator, so I'd probably do that. Okay, we're going to do number 8 next. Anybody want to go to the board and do number 8 for me? Okay, so no one wants to do it? Okay, so this is 2 by 2, and the other guy is 2 by 4. And so I can do the multiplication. And so my answer is going to be a 2 by 4 array. Darn, I thought sure I wouldn't have to do this one. 2, 0, 1, minus 1. At least I have easy numbers to do. Oh, good. 2, 3, 4, 5. 1, 0, minus 1, minus 3. First row, first column, 4. First row, second column, 6. First row, third column, 8. First row, last column, 10. Second row, first column, 1. Second row, second column, 3. Second row, third column, 5. Second row, last column, 8. So all we're doing, because we didn't practice multiplying, dividing, and adding, that's all we're doing now, right? So we're back to third grade math again, filling in matrices. All right, back on to number 10. 3, 0, 2, 5, 1, minus 2, 1, 0, minus 4, 2, 3, 5. Okay, so we have a 2 by 3, and we have a 3 by 2. Those two are equal. We can do the multiplication. When we get done, we're going to have a 2 by 2 when we get done. First row, first column, 9. First row, second column, 10. Second row, first column, 5, 1, minus 5. Second row, second column, 0, 2, minus 8. And if you question yourself, put it in your calculator, have the calculator agree with your answer. If not,
I never question.
well, that is good. Okay, number 12. So we have a 2 by 3, and we have a 3 by 3. So this multiplication can be done. And when we get done, we're going to have a 2 by 3 guy when we get done. All right. I like to check the order first to make sure we don't have one we can't do. So far, that hasn't happened. Stupid author, anyway. Minus 6, 0. I mean, he should at least give us one that we can't do. 1, minus 5, 0. So I like them with zeros in it. That makes it easy to do. Minus 1, 4. Okay, first row, first column. 2. No, this is a 3 by 2. What's wrong with the front row? This is a 3 by 2, and it can't be done.
That's what I was trying to tell you, but
Can I-
That's what you do.
I said it.
Oh.
You said, no, you can't.
Yeah, I tried telling you about it. You didn't get it.
Because the other one wasn't, cannot be done. Thank you. You get hungry?
Number 12.
You can't be done.
Okay. We've moved down to number 22. Not to speed up or anything, but number 22. 1506. Notice there's no commas in the matrix. Matrix has no commas. It only has positions. Okay, so this is a 1 by 4, and this is a 4 by 2. So our answer is going to be a 1 by 2 when we get done. Okay, first row, first column. Got a 1, I've got a 21. I've got a 21 and 18 for 39. 39. I got a 3. I've got a minus 15 for a minus 12. I got a minus 12 plus 18 for a 6. All done. Okay, we're going to do 24 next. And we have an A guy. This guy here would be a good one to put in your calculator because you're using the same matrix over again, right? And we got a B guy.
Bless you.
Sorry, but it's just
Bless
not like
you.
And we want A, B.
My whole foot.
Fine. First row,
Sorry.
first column, 10. First row, second column, 7. Second row, first column, 5. Second row, first column, minus 2. Okay, and then we want a BA. BA. First row, first column, minus 4. First row, second column, 2. First row, first column, 15 minus 8, 7. 15 minus 8, 7. Second row, well, no, this guy, that column. This guy, that column, 12. Notice that AB is not the same as BA. What does that mean? No commutation. So matrix don't commutate. Bummer. Now we're looking for A squared. A squared. First row, first column. 9 minus 8. First row, second column, 8. Second row, first column, minus 11. Second row, second column, minus 7. But see, if I would have put these guys in my calculator, I could have just gone A, B, got the answer out. BA, got the answer out. A squared, got the answer out. So at that point, it probably would have been easier to do that. Okay. If I have 1 times A, what do I have?
1, okay.
A. Okay. If I have A times 1, what do I have? A. If A is a matrix, is there something that I can multiply? Is there something that I can multiply by A by and get A back? That's the issue. And there is, and it's called the identity matrix. Okay, so that's cool. So if I want a 2 by 2 identity matrix, I have 1, 0, 0, 1. And so I've got A, B, C, D, and I'm going to multiply that by 1, 0, 0, 1. First row, first column A, first row, second column B, second row, first column C, second row, second column D. Seemed to work. 1, 0, 0, 1 times A, B, C, D. First row, first column A, first row, second column B, second row, first column C, second row, second column D. So it looks like that is, in fact, the identity matrix. So if I wanted a 3 by 3 identity matrix, I go 1, 0, 0, 0, 1, 0, 0, 0, 1. If I want an identity matrix that is 4 by 4, Go 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. You see a pattern? Yeah. So our identity matrix has 1s on the diagonal. We call it the diagonal. I can't imagine why. And 0s every place else. All right, so now that we know that, for each matrix, show that I and IA is equal to A, where A is the identity matrix. So we're going to do number 30. Number 30. Minus 4 minus 3 1 0 1 0 0 1. First row, first column, minus 4. First row, second column, minus 3. First, second row, first column, 1. First column, 0. Yep, it works. Do I have to do it the other way? Only because the problem said to do it again, so I'd have to do it. But obviously I've already did it because I did it when I did it with A's and B's. If it worked with A, B, C's, and D's, it has to work with row numbers, right? First row, first column, minus 4. First row, second column, minus 3. Second row, first column, 1. Second row, last column, 0. And I am, that works fine too. Wow. All right. Well, let's move on to 15.3. So I've got a matrix, and I've got its inverse. And if I take A inverse A, I'm going to get the identity matrix. And if I take inverse A, I'm going to get the identity matrix. So the inverse of the matrix A has to be something such that if I multiply it times A, either before or after, I end up with the identity matrix. That's what I have to do. So now the issue is, what do we do to get the inverse matrix? That's what we want to do. All right, so what I would do is put it on my calculator and tell it to give it to me, right? Oh, good plan. Now, the identity matrix is a square matrix, right? So it's 1 by 1, or it's 2 by 2, or it's 3 by 3, or it's 4 by 4. So because the identity matrix is a square matrix, A and A inverse has to be a square matrix. So if A were 1 0 0 0 1 2, and I wanted to find inverse A, I would say no, foul, can't do it. A is not a square matrix. There's nothing I can do. There's no way I can multiply anything by A and get a 3 by 3 out. Okay, it's not going to work that way. Okay, so that's the case. All right, so what am I going to do? I've got 1, 2, 3, 4. That's my A. And I want to find inverse A. And somebody take their calculator and get the answer for me so that when I get to it, I know it's right. 1, 2, 3, 4. So what I'm going to do is go 1, 2, 3, 4, put 0, 1, 0, 1. And I'm going to make a matrix that looks like that. And then I'm going to do elementary row operations on this matrix until I get the inverse matrix on this side. When I get the identity. When I get the identity matrix on this side, I will have the inverse matrix on the other side. So that's the plan. So I can add rows, I can subtract rows. I can multiply a row by something. I can subtract it. Okay? Those are things, that's what I can take the square root of things. I can do all kinds. Anyway, elementary, easy things. I'm not doing a quadratic thing or anything like that. All right, so what I'm going to do is I'm going to go times 3, and I'm going to subtract the top row from the bottom row. All right, times 3. I'm going to keep the top row. it's going to stay the same, times 3 subtract, times 3 subtract, times 3 subtract, times 3 subtract. Okay? Then I'm going to take the bottom row and I'm going to add it to the top row. 1, 0, minus 2, 1. All right, and then I'm going to go and multiply the second row by minus a half. 1, 0, minus 2, 1, 0, 1, 3 over 2, minus 1/2. Okay, now I've got the identity matrix on this side, and I'm saying that inverse A is minus 2, 1, 3 over 2, minus a half. Did anybody ask their calculator what the right answer was yet? No one did. No one's done it yet, so that means we'll have to try it out. Is 1, 2, 3, 4 times minus 2, 1, 3 over 2, minus a half. Is that the identity matrix? First row, first column. I've got minus 2 plus 3, or 1. First row, second column, 1 minus 1, 0. Second column, first row, second row, first column. I got minus 6, minus 6, 0. First row, second column, 3 minus 2, 1. My answer is correct. Yes, sir.
I have to go. I have an appointment.
Please do. Yeah. Yeah, right there. So now I found the inverse matrix. Now I'm going to go to my calculator. I'm going to turn it on. I'm going to go to matrix. I'm going to go to edit A. I'm going to call it a 2 by 2. And I'm going to put a 1 in. I'm going to put a 2 in. I'm going to put a 3 in. And I'm going to put a 4 in. Okay, I'm going to quit out of there. I'm going to go back to matrix, go to math, and wrong one. Back to matrix, go to math, and go down to, oh, bummer, twice in a row. Matrix, go to math, come down to inverse. So I want inverse, bummer. All right, delete. All right, I want A first. Second function, matrix, A. Second function, matrix, math. Did it again. Second function, matrix, A. Second function, matrix, math, inverse, enter. Minus 2, 1, 1.5, and minus a half. Exactly what. So my calculator can do it for me too. I can get an inverse matrix. Now the cool thing about an inverse matrix is that if I have 2x plus 3y is equal to 4, and I've got 4x minus 8y is equal to minus 13. Let's say I've got that. I can write this as 2, 3, 4 minus 8 times the matrix xy is equal to 4 minus 13. So I could write these two equations, two unknowns, in like that. And in general, I could say that that's AX is equal to C. Okay? So now if I could find the inverse of this guy, and I wrote inverse A x is equal to A inverse C. Well, A inverse A becomes the identity matrix, so I have x is equal to A inverse C. So if I had the identity matrix and I multiplied it by the constant C on the other side of the equation, I could find my x. So this is x and y sitting over here, and this is the A inverse guy sitting there with the C guy, which is 4 minus 13. So that's just another way you can solve simultaneous equations. So you're on a desert island, you solve the same simultaneous equation 4 different ways already, and you need a 5th way to do it. Well, here's a 5th way to solve the same one over again. Okay. Time to go away yet?
Yes.
I don't even have to do a problem? Okay, I guess not. I don't have to.